In this video, we're going to be talking about plane geometry, specifically angles. Now, what are angles? Angles are just formed when two straight lines meet. So, for instance, if you have a straight line and there is another straight line that meets this straight line, then an angle is formed. An angle is formed here, an angle is also formed here, and also this part. So angles are just formed when straight lines meet or intersect. Now there are types of angles. One of them is acute angles. Acute angles are just angles that are between 0 and 90 degrees. So if we have an angle of 60 degrees, we can say this is an acute angle. We also have obtuse angles, and these are angles that are between 90 and 180 degrees. An example is 120 degrees. Now, complementary angles are two angles which add up to 90 degrees. So if we have 60 degrees and 30 degrees, the sum equals 90 degrees. We also have supplementary angles which add up to 180 degrees. So we can have 120 and then 60 degrees, which equals 180 degrees. In this case, we're going to say that this is supplementary angle. Now, the next thing we're going to look at is angles which meet at a point. Now, the sum of angles which meet at a point is 360 degrees. If we have a point and then there is a straight line through it, we are saying that the angle which is met around this point is 360 degrees. That is from here to here. And so that is it. Angles which meet at a point is 360 degrees. A clear representation of this is going to look like this. Let's say we have two lines that meet this way and another line that meets the two lines. If this angle is A and this angle is B and this angle is C, then from the property of the angles that meet at a point, we're going to say that the sum of A, B, and then C equals 360 degrees. And then C equals 360 degrees. So let's look at an example. We have this diagram. This portion is A. This is 20. This is 120. And this is 100. We are to find the value of A from the diagram. Now we know that this is a type of an angle which is formed around a point. So this is the point. And then we're having an angle that is formed around the point. And so we know that these angles sum up to become 360 degrees. And so we're going to derive an equation that says that A plus 20 plus 120 plus 100 equals 360. If we had 20 plus 120, that is 140, plus 100, 240. So you have A plus 240 equals 360. You make A the subject, 360 minus 240. And this is going to give us 120 degrees. And so A equals 120 degrees. Let's look at another. Another example. Consider this diagram. The angle formed here is 2x plus 30. The angle also formed here is x plus 10. And the angle formed here is 4x minus 30. We know that this is also an angle formed at a point. And so we know that the sum of the individual angles sum up to 360 degrees. And so we're going to construct the equation. That is x plus 10 plus 2x plus 30 plus 4x minus 30 equals 360. Now x plus 2x plus 4x, this is 3x, this is plus 4, 7x. So we have 7x. We add 10 plus 30 is 40, minus 30 is 10. So plus 10 equals 360. Now 7x equals 360 minus 10. 7x equals 350. We divide by 7 and x equals 50 degrees. And so the value of x in this diagram is 50 degrees. Adjacent angles on a straight line. Now, if you have a straight line and an angle is formed on the straight line, let's say this is A, this is B, and this is C, then we are saying that the sum of angles on this straight line is equal to 180 degrees. And so A plus B plus C equals 180 degrees. It could be turned. That shouldn't confuse you. If you have A here, we have B here, and we have C here, A plus B plus C equals 180 degrees. So far as these adjacent angles are formed on a straight line, if the line is like this and this is A, we cannot say A equals 180 degrees. It must be formed on a straight line. We can have something like this also, whereby we have A, B, C, and D. Since it is formed on a straight line, AB, line AB is a straight line, and this is the point of intersection. And so these adjacent angles are formed on a straight line, and so the sum is equal to 180 degrees. A plus B plus C plus D is therefore equal to 180 degrees. Let's look at an example. You have a straight line. This is the point of intersection. We have 70 degrees here, 30, and then we have x. We are to find x from this diagram. We know that the sum of the individual angles on the straight line is equal to 180 degrees. And so 30 plus 70 plus x equals 180 degrees. 30 plus 70 is 100 plus x equals 180. X equals 180 minus 100. If we subtract 100 from 180, we're going to end up getting 80 degrees. Don't forget your degrees. Even if you are not adding them to the method, the final answer must contain the degrees. And so that is it. We also have what we call right angle. Now, any angle of the magnitude 90 degrees is called right angle. For instance, if you have this and the angle between is 90 degrees, then that particular angle is termed as right angle, and it's usually denoted by this right angle sign or symbol. So anytime it is 90 degrees, they won't necessarily write it as 90, but they are going to indicate with this sign that it is 90 degrees, with this sign that it is 90 degrees, and that should tell you that it is a right angle triangle. Sorry, it is a right angle, and that should tell you that it is a right angle. An example: you have to find A from this diagram. You have to find A from this diagram. We can observe that this is a right angle, and so A plus 30 equals 90 degrees. What we're gonna do is that we subtract 30 from 90. A equals 90 minus 30, and this equals 60 degrees. Another one we're gonna talk about is vertically opposite angles. Now the theorem states that vertically opposite angles are equal. If you have something like this, and these two lines are straight lines, CD. AB is a straight line, CD is also a straight line. We can say if this angle is A and this angle is B, this angle is C and this angle is D, we can say that A equals B and C equals D, in the sense that they are vertically opposite. A is vertically opposite to B, and the theorem states that vertically opposite angles are equal. C is also vertically opposite to D. You could be confused when they bring something like this. And this is A, this is B, this is C, this is D. You should note that A is not equal to B and C is not equal to D. This is because this line, let's say AB, is not a straight line. The straight line could have been through this portion. Hope you're getting it. That is the straight line. Line AB, in fact, is not a straight line. And so A cannot be equal to B and C cannot be equal to D. With vertically opposite angles, there should be straight lines between them in order to be able to identify the vertically opposite angles. Let's take an example. Consider this diagram. This is 120 degrees. This is A. This is 50 degrees. We are asked to find the value of A in this diagram. Now, let's determine whether this is vertically opposite angles. This is a straight line AB, and this is also a straight line CD. Now, this angle is the same as this angle. Hope you can see, because this is what is formed. 120 here, and the whole of this thing is the same as 120, but it has been divided into A and 50. Hope you're getting it. And so we're gonna say that A plus 50 equals 120, And if this is small a, since I'm using a variable a, let me change it. Let's say this is b and this is c. Then b equals c from the law of vertically opposite angle. So let's continue. A plus 50 equals 120. And so a equals 120 minus 50. A equals 70 degrees. Just like I was saying, never and ever forget your degrees and attachment to the magnitude, the values. Thank you for watching.